So, welcome everyone. Um, and of course, something just happened to my settings. All right. Hi everyone. This is Christian. I've been with VMware for 11 years, 11 and a half almost. Yeah, I think so. And I've been working on vSAN for the last 8.5 years. vSAN is our enterprise storage product. And Joe invited me a few weeks ago to host one of these TGIKs, and there was somebody on the chat who was asking, what does that stand for? It's thank God it's Friday, or in this case, thank God it's Kubernetes. And yeah, this is my first TGIK. In fact, the first time doing such a YouTube live stream. This is exciting and new, and you know, I will. It will be exciting to fat finger everything and for the whole world to see. So. Um, Let me take a look at the chat. Hi, Martin. Um, Hi to the Netherlands. I actually live in Germany, so this is late for you. Thanks for joining live. Hi, Steve. And by the way, I'm still getting used to the lag. There's a lag between me saying stuff and you hearing it. Uh, Hi, Mark. Welcome to this episode. So So basically for today, I want to talk to you about Grafana Loki. And of course on this screen as well, the YouTube chat is the wrong size. Let me fix that before we get fully started. All right, so this looks better. Yeah, I wanted to talk to you about Grafana Loki today. But before we do that, we do the usual, which is sort of a community update and what's happening out there in Kubernetes. Um, I'm actually not an expert yet in the community. I'm just starting. I actually commented on my first pull request, or not on somebody else's pull request, about a cap just a week ago, my first contribution to Kubernetes. So I'm still ramping up. I was able to attend KubeCon EU. That was exciting. So I'm new to this, and our experts who have been with Kubernetes for years have actually helped me set up for today. So they have been setting up a bunch of things that we can talk about a little bit more. In particular, let's actually zoom in a little bit so that this is a little clearer. Um, Going through a little bit of an update, actually, given that I'm new to the community as well, probably newer than most of you on this feed, um, I wanted to just do a shout out to those projects. I'm actually not an expert on any of these, but KubeCon Shanghai just happened or is happening, and all the videos are already starting to pour in. This is pretty awesome. I saw the same thing with KubeCon EU. It was really exciting to see everything up really quickly afterwards. So I will personally be checking out the videos over the weekend probably or next week to see what was presented. I didn't get a chance to do it live this week, so that's going to be interesting. Um, Also, the CFP process is open for San Diego, and it's actually coming up on July 12th. It will close, and actually, I need to get my personal submission in. I hope I have an interesting topic and it will get selected, but you should all take a look at that. Um, Hi to Strasbourg, another European person joining really late in the day, so appreciate that. Thanks for that. Um, so All right, so basically, let's go through the other things. So this week there was no Kubernetes release, which is weird to me. I'm from VMware. We do releases every like 6 months. We thought that was really fast. We used to do 18 months or 24 months when I joined the company. So the notion that it's big news that there was no release this week is actually a big deal for me. But there's some interesting articles about 115 pouring in. And personally, the future of CRDs, that has been really interesting to me because um, we're working on a few CRDs to on the Kubernetes front, and you know, they're still a little bit immature, I guess. There's a lot of things that we can improve about CRDs and how they're done, and there's a lot of work that actually went into 115, and there's a great article about this. I will personally be checking out more about all the updates on that front and try them out. I haven't seen it yet. I mostly saw it on Twitter that there's a lot of improvements and they sound really exciting. Um, there's also obviously 116 starting now with 115 just hitting the market. So check out a lot of that material about what's coming out of 116. I will, again, being new to the community, I will actually do this as well and start checking out. In fact, I started attending the storage SIG meetings, and so I'm excited to follow 116 a little bit closer myself after just getting started and sort of seeing what's out there. Um, let me see what else. Um, we have the CNCF doing a webinar on pod security policies, and if I'm not mistaken, we actually did a TGIK on pod security policies just 2 weeks ago. Um, this is an interesting topic to me as well because, as more and more production workloads are on Kubernetes, I guess there's a lot more need for strong security, and RBAC has been one of the things I've been looking at, and I think there's lots of interesting stuff that is already happening and that could be happening. So this might be interesting for people to check out this webinar here. So what else? Someone did a crazy cluster on one board, Kubernetes Home Lab. Um, so, right. So I saw this earlier in the prep for this. Let's actually check this out. Um, so I guess this is a Raspberry Pi with 7 modules, and the 7 modules basically run 7 Kubernetes nodes, I guess. And so we have a whole bunch of stuff all running in such a small form factor. So that's pretty exciting. Um, and it's pretty small form factor. So any hardware geek will probably be super excited about what's happening in that space. I know that for VMware products, home labs has always been a big thing. So getting down to that size is actually quite exciting, and I think something that as VMware we haven't you know we haven't scaled all the way down to that yet. I believe. So this is interesting. Um, and another community update here is this CI/CD blog post series, and this is actually something I want to check out because CI/CD is something that I personally worked on at VMware for several years. We built a lot of homegrown systems because at the time that we did them, there wasn't much out there. But these days there's a lot happening, and in fact, I think Kubernetes offers an opportunity to do a lot more on CI/CD in terms of actual integration testing between, putting together a whole application with all its microservices. And so I will personally be checking out this blog series and see what's going on. To me, a really exciting topic that I think will evolve quite a bit over the next few years as well. And finally, we have an article about debunking security myths. And I guess this is one of the interesting things about Kubernetes. We have a large community, and there's a lot of information out there, and a lot of information that you might not. Oh, the sound is low. Can other people confirm that my volume is low? Because earlier we had it a little bit louder, and people suggested that I should tune it down. By the way, hi to Sweden. No, Spain. To Federico. Thanks for joining. All right, sounds like it's a bit low. All right, so let me see. Let me make it slightly. I will go slightly higher, and if people complain, let me know. But I'm okay. So there seems to be mixed feedback on this. So I will mostly keep it where it is. Hi to India, guys. You need to sleep. Like India must be middle of the night right now, like midnight or something like that. So excited for you to be here, but make sure that you sleep. Sleep is important. So yeah, basically, a bunch of myths around security, and someone from our team actually, 1:40 a.m. All right, that's even worse than I thought. Um, Yeah, the all the settings, getting them right has been really tricky. Thanks, Joe. And in fact, I'm a digital nomad. I actually don't have a real setup, so I'm in Palo Alto this week, and I'm using our office here to do this at all because I tried to do this from home with the equipment I have at home, and that just didn't work at all. So had to scrounge up the equipment, and I'm not set up like Joe, who has basically a full recording studio at this point. So hope this setup is working for everybody. But yeah, so a bunch of myths around here around security. Pod security policies are apparently not hard. I haven't verified this myself, but a bunch of interesting things here that I will be checking out as well. And so take a look at this. Our internal vetting said this is actually interesting and not a bad source of information. So go ahead and check it out. I will personally be doing more of that myself. So so with that, um, so with that, I think I will start diving into what I have, well, semi prepared for today. For me, this is weird, not being fully prepared, not having scripted everything. But Joe tells me that's the whole point of this format, that you see me live and you see me screw up. So that's the exciting part of about this. So what my topic is Grafana Loki, and I got a chance at KubeCon to see two talks by Tom Wilkie on this, and he did a fantastic job, and it got me really interested in Loki, and I thought I was going to check it out. And when I was checking it out, I felt like, wow, there's a lot here that's super interesting. I should actually do an analysis, and then I thought, well, if I'm checking it out, if I'm doing an analysis, well, actually, I should be sharing this with the community, and I should be using this as a chance to do a first TGIK. So here we are. Um, and essentially, what Loki is a index-free log aggregator. And my first question to Tom was, what's index-free about it? And so basically, the notion is that existing log aggregation systems like Splunk, or if you use like Elasticsearch, they are all pretty much uh, sort of strong on being able to search for anything. Everything that comes in, all the strings that come in are heavily tokenized so that you can do an arbitrary query and it returns in just a snap. And that's awesome. And it's awesome, especially when you do business intelligence. If you do machine learning on this, and you want to be able to run these arbitrary queries and you want to get some insight from that. Um, and that's, I guess, a really important thing these days. But you know, in Kubernetes, we are a large community of developers. And quite frankly, most of the logs I produce, I have a hard time imagining that somebody can really get business intelligence out of it. I really want my logs to do debugging. And if you want your logs to do debugging, do you really need to tokenize everything, or could, a good old grep actually be a solution? And I think Loki basically takes a interesting approach in that. And it basically says every pod that you run, or even within a pod, you have a few streams of data, and you basically, just like Prometheus, you take all the metadata associated with a pod, like the pod name and any key value pairs that you put in Kubernetes, and that's your metadata. Your time range is your metadata, and that's what you can do a search on. But everything else, doing the actual text search, you just use grep. And the promise is that this is 10x, 50x, 100x cheaper than the competing solutions that actually do the full indexing. And that sounds appealing. At the end of the day, we all care about cost. So so let's get into it. This is sort of what got me interested in it, and now I want to see how we're doing. So before we do this, let me actually set up. So being a VMware guy, actually for today, I created an AWS account. I actually did not have one, and I created one to be able to run this demo because I wanted to use Amazon S3 and I wanted to try it out. And I just needed a little bit of an EC2 instance, and So I created an account and I will actually start with setting things up. So let me launch an instance for what we're going to do today. Um, and I think I wanted to have an Ubuntu. I wanted to have the 1804 LTS. That sounds good. And I think I decided for the demo to do a T2 large, 2 vCPUs, and 8 gigs of RAM. We're actually going to later evaluate a little bit whether that's a good choice and what my choices are. But let's start with that and let's launch that. So yes, I know about SSH. All right. So this is happening, and while this is happening, let me actually start how any developer starts, which is you Google things, Grafana Loki. So we get to the GitHub page. Um, so I will actually set up a little one node Kubernetes on that one EC2 instance. And when I prepared for this, I just got here and, I have to admit, in good developer fashion, I didn't even read this full wiki page. I just searched for the blue getting started docs. So let's get started. And I'm not using local Docker. I'm going to use Kubernetes and I'm going to use Helm. So let's go here. And all right, this is what we're going to do. We're going to deploy Loki. We're going to deploy Prometheus, and I'm actually going to explain what those things are. Oh, hi to Paris. Wow, lots of folks from Europe. I didn't expect that. Cool. So let's take a look. Let's take a look at what's happening on to our instance. Let's view my instances, and it's initializing. So I guess this is the awkward moment where I need to wait for things and just talk while we're waiting. One thing as a VMware guy that has been interesting using AWS is, hey Christopher, hi to Germany. One thing that has been interesting to me is that when you use the VMware software, one of the nice things you get is you get the interactive screen of a VM, and that's super cool, and that's really useful. But what you get here is actually sort of you click on connect, which I thought was going to get me the screen, but it's actually about connecting SSH. And as a developer, I really appreciate this, and this was new to me, and this actually makes a lot of sense. Because I actually don't want to use the screen to set things up. I want to connect to SSH, so I like this. So, so while this is waiting, maybe I can talk a little bit about the architecture of Loki. So for that, I've prepared a little diagram, and I love drawing on my iPad, and so excuse the scribbling, but here basically what I'm doing is I have the Loki components, which is there's a distribution element, which is basically like a load balancer, and then we have these ingesters, and they each hold a bunch of these log streams. And then ultimately, we're writing out to S3 in terms of the actual data. And S3 is really cheap at storing lots of data, and it's particularly cheap if we do very few requests. And so that's an interesting model, and we're going to see that Loki actually does really well on this. And so the idea is that if I have a pod running in Kubernetes, it would be one stream, and I can further subdivide that into multiple streams. But by default, let's say we have one pod as one stream, and so that stream will essentially go and hi William. Did you just call me a dinosaur? Seriously? On live chat? All right. So we have this pod, and it creates a log stream, and the ingester will actually buffer it in memory until it has a large enough buffer that when gzipped creates a large enough object to be put into S3 that it's economical. And we're going to actually talk a little bit about sizing later, because I found that that is sort of a really important and interesting topic to me. But the notion is that we're keeping this in memory, And when we have the full memory that we wanted to get, we gzip it and we write it out to S3. And so this is the general architecture. And then as Tom explains in his talks, basically the ingester can scale out, and the distributor will figure out how to send everything to the various different ingesters. But let's keep it simple for now with this architecture diagram, and let's take a look at our EC2 instance. Oh, interesting. On Azure, you can get a serial console. That sounds useful. Hi to Virginia. At least we have one person from the US spending their afternoon with us, and not just Europeans and Indians who should be in bed, or should at least be out on a Friday night doing something more fun involving beers. Oh, I see, William. You weren't talking about me. Cool. So let's take a look here. So let's see. Let's click on connect. Let's get our instance and let's connect to it. Yes. And this obviously fails because this is wrong. I want Ubuntu. All right, and we are in. Let me know on the chat if the font sizes aren't working out felt well for you, so I can adjust if that's the case. Hi, Monica. Hi to Tampa. So I prepared a little bit for this. So basically, we just need to set up a bunch of stuff. So let's do that. So basically, I decided for today, given that, I'm a newbie, and so other people, Kubernetes is a growth area where, there's lots more people ramping up every day. And so I decided for today, I'm actually going to start from scratch. I'm starting with a fresh VM, fresh instance, and I'm actually going to install everything, including Kubernetes, from scratch. And so I'm setting up Python. I'm setting up restart services, sure. I hope that didn't disconnect me. But yeah, so I'm basically setting up everything, Kubernetes, Python, and a bunch of other things that I will use, like top and such. All right. So let's see. Some more commands that I'm pasting in. All right, perfect. Font looks good to people. That's great. So I decided to use microcates because I saw it on another. Oh, interesting. I saw it on another episode of TGIK, and it looked simple enough, and indeed, it worked really well for me. So let's see. All right. So apparently, you shouldn't be enabling DNS too fast after enabling Kubernetes itself. So what did I do? I just used sudo snap install microcates. And then I used microcates enable and enabled DNS, which was weird to me. I felt like DNS is such a basic service that should always be running, and so it tripped me up in the prepare that it wasn't just enabled. But figure that out. All right, so now we have a Kubernetes, which is great. So actually, let me set a kubectl. By the way, I think if saying kubectl is frowned upon, and I guess you will just have to deal with that. Because I can say kubectl, but I don't like to. All right, kubectl See, you see me fat fingering everything. Get nodes, and we have one node. And that's all we're going to need for today. So basically, I think this should give me a sufficient setup, right? Oh no, it doesn't. Actually, the next thing I want to do is I also need Helm. So let's see. Okay, so let's do a sudo snap install Helm. And we need to do a Helm init to install tiller. All right, this has also been done. And now I guess we can actually resume going here, going to, oh, thank you. The episode on microcates is posted on the chat. So definitely go check that out. I thought it was quite easy, and all right. So let's see. Sorry if I'm not used to you guys seeing everything I do, so I need to do better job at managing my screens. So let's see. We are supposed to do a Helm upgrade and install Loki and the whole Loki stack. And I'm, in good developer fashion, I will simply blindly copy paste whatever I'm being told to do. All right. Tells me that I should be doing this. Oh, right. So I should actually read what it says. Okay, sorry. I need to add Loki as a repo. Now I do update. All right, and now I can actually use it, right? All right, this worked. Cool. And it set up a whole bunch of different things, and I'm going to check out what it actually set up in a moment. But for now, I will just go with it and ignore all the things that it actually did. I will just keep following along. And so it also tells me to install Grafana, which makes sense. All right, it suggests that I need an admin password. So, all right, we have our admin password. It also suggests that I want to copy paste this. So I do it. Oh, no, I don't want to do that actually. All right, so we will use this in a second. And now I need to actually so now it shows that I'm a noob because I don't know if this is actually the best way. You guys will be able to tell me. But I'm using kubectl expose, and I'm going to have the deployment, my Loki Grafana. I'm going to do a node port service. I'm going to call it my Grafana external, and I'm going to put it on port 3000. All right, and I'm using kubectl services, pods, config maps. Let's take a look at what all we have. So in terms of services, we should now have my Grafana external on this port number. Great. So now what I'm going to do is I'm actually going to export that in the firewall rules. And this is another crazy thing to me that, I created a VM that's on the public internet. And so I will just create a firewall rule, put my IP address in, and this is all safe. apparently. I'm too much of an enterprise guy by now to feel like okay just putting VMs on the public internet, and I'm pretty sure that there's at least 2 or 3 people on this call right now or on this feed right now trying to hack me. So go at it. If things blow up, you are awesome. So let's try to connect to this. So first, though, I need to get back to, where did I start? I started with my IP address. So let's see. Grafana is loading, admin, and well, this is where we needed the password. We printed it somewhere. It's over here. All right. All right. Let me know if the font sizes for Grafana and everything also work out. I think this looks okay-ish, but let me know if it doesn't. So we go to Grafana, we say we want to add Loki, and now we're actually within the Kubernetes networking, and thank God I enabled DNS earlier. So this should work. And it does. All right. And Grafana has actually been recently adding this explore mode. So, um, what we need to note is we're basically, from what I understand, running top of 3 versions right now. And I've been doing this over the last several weeks using the explore feature, and depending on the day, sometimes it works better than other days. It's generally moving into the right direction, but occasionally there's a few regressions. So let's see what we actually get today. So we're going to this explore mode, and the cool thing is that while Grafana was traditionally more of a dashboarding tool where you create your dashboards and that's how you looked at your environment, Explore is really more interactive. It's supposed to be for your interactive troubleshooting, both for Prometheus as well as now for Loki, and they're actually both in this Explore mode. And so let's take a look. The labels have already been populated, and what we can see is actually, what I said earlier. What Helm was deploying was Loki, Prometheus, and Grafana, and we're going to talk about what these are in a moment. But the Grafana we just deployed, and that's what we're using right now. So let's take a look at that, and so we can see the logs for that, and we can alternatively look at our Loki. And so now comes the moment of truth, because I want to actually do a grep. And when I prepared, the grep didn't work. Right, and so somebody can tell me if I'm doing this wrong or if there is a problem. But if we go back to Loki, and actually, or is it down here? So instructions for adding things. So let's see about how to actually use Loki. So there should be, right, once you have Prometheus, Loki, and Grafana running, continue with our usage dogs. So this is what we want next. Let's see. Right, so we were supposed to add the data source. I did that. This was all so straightforward that I didn't even check the documentation, because this was so easy. But now, so we're going to try this out next to actually enter more interesting selectors. Right now I use the drop down, but this is supposed to work. So we're supposed to be able to do the pipe equals and specifically search for error. So let's try this again. This was in my browser, not on this command line. So we're supposed to be able to do this, and it's supposed to filter by that. It doesn't, though. And I've definitely seen a demo where this worked. I've definitely tried this out a few weeks ago where this worked. But I would think that only this line should be showing up and it should be correctly doing a grep on that. So it didn't. So if anybody on the chat who knows what the problem might be, or if this is on my end, or if I'm just using a build from top of tree that isn't quite good, let me know. But essentially, I can actually. Hmm, Paul suggests that I can actually do without this. No, that's a syntax error. Let's look at the usage again. Just can be changed. Line matches regular expression. So no, I think this should be working. And I think this is what I saw both David and Tom do in their demos. Well, no, this also has it? Oh, I see. Okay, well, now it doesn't find anything. So, yeah, thanks, William. All right, now it's doing something different. Okay, so it has our log messages to tell me that I fat fingered everything, but it's still not doing the actual filtering. So who knows? Yeah. Um, yeah, this doesn't do the right thing either. Oh, this works. Okay. Okay. Cool. All right. We found a way to make it work. Um, so the problem was in front of the keyboard, but also a little bit in this tutorial. This tutorial should have been more clear if this is what I'm supposed to do. Okay. Cool. All right. So, yeah, Paul, thank you. This is working now. Cool. So so now let's actually use this. So what I was thinking that we could do was going to be that we use kubectl apply, and we're starting a new pod. And so I prepared a new pod. And I just want to use this very simple pod, um, and hope these font sizes also work out, and the colors. But essentially, this pod is called example. It has a special TGIK label, and otherwise it's just an Ubuntu. I'm running bash, and I'm just running a while loop that prints the date to standard out and does a sleep one. So this will end up in the Kubernetes and Docker logs. So let's copy paste this into our kubectl apply. We've created a pod, and so now we can do kubectl logs on this pod, and we see that every second it's printing something. Cool. And now we should be able to search for that. So let's do that. So I wanted the pod that has TGIK, and it actually does autocompletion. So it has figured out that there is an episode 81, and I can look at that, and voila, this works. And if I now do a search, this also works. Awesome. Cool. So, so basically, this is really convenient and interesting because the same labels that we use for Prometheus monitoring are actually now also the labels we use for logging, which makes a lot of sense. And there was this nice talk on the main stage, a keynote on the future of observability, and it actually called out that this combination of being able to jump between metrics and logs in this fashion is going to be a really powerful thing that's going to be there in the next couple of years. And I think this is an interesting example where we can actually use metrics and use the same labels to find our pod as we can use now for logs. And this does indeed sound very powerful. So cool. Um, so with that, what did I want to do next? So so basically, we've used it, and this seems to be working. So what does this actually do underneath? Let's actually check this out. So so we already looked at the fact that there were config maps and pods, and so let's take a closer look. So there's a Loki pod. There is a Grafana pod. These are the two ones that we expect. So the Loki pod is the one that's actually implemented in the backend that has all the services like the distributor, the ingester, and this is actually one thing that's interesting about Loki. I really appreciate this. It has a monolithic version and a microservice version. You can actually just run one container that runs one binary and it does all the functions, or you can tell it to actually run in microservice mode, and every pod just does a little piece of the larger puzzle. And so here we're running this in the very simple mode, which is the monolithic mode where everything is happening together. And then we're running Grafana for the UI. And all the ingestion and all the querying happens through the Loki 0 pod that's coming from a stateful set, I assume. And then we have the Prometheus pod. And the Prometheus pod is interesting because this is coming from a daemon set. Right, so we have the daemon set down here. And so let's print that. Let's do a kubectl describe. And so what this does is basically on every node, it will run Prometheus. And Prometheus, the idea of the name is basically that it's collecting things the same way that Prometheus collects metrics. It does that for logging. So it's the Prometheus style tail. And basically, tailing means it's basically monitoring all the containers running, and so for that, it's mounting in a bunch of things from the host path. So it's mounting in the run directories, the container directories under varlib docker, varlog pods. So basically, it gets access to the host, runs in a more privileged mode, and hence it has access to what's happening, and so it can actually monitor for all the pods coming up. Like we did for our example pod, it can see them, it can start streaming, then it has access to the metadata, and it can do all these cool things. So that's awesome. So that's Prometheus, tail on all the pods and collect all the Prometheus style metadata and stream that to Loki. And in fact, where does it stream it to? It streams it to here, right? To the to the API, the push API for Loki. So this is actually something I checked out because this is a REST API that you can also call directly. So you don't need to use Prometheus, but Prometheus in the in the Kubernetes context is particularly useful. But you can actually connect to it from anything, and you can stream logs into Loki, and that's actually going to be something that we explore next. So basically, what I now want to do. So we have Loki. It works. People say it's awesome, cool. But I wanted to actually understand from a storage perspective, given that I'm a storage person and I'm an infrastructure person, I wanted to sort of analyze this from an architecture perspective, from a design perspective, and understand the cost better. Right now, the GitHub pages don't yet have a cost modeling, and I asked on Twitter whether that's something that exists, but it doesn't really exist yet. But I think this is cool. So for the remainder of this TGIK, I actually want to dive a little bit into exploring a cost model, and for that we need to first understand things a little bit better. So let's see. where do we start? So what did I prepare? I prepared, um, well, actually, before we run the benchmark, let me actually do one more thing. So I want to actually also add a Prometheus. So Prometheus is what we use for monitoring, for metrics. And so what I'm going to do is, in being a good citizen, the Loki container also exposes a slash metrics REST API for Prometheus. And I'm going to just start a Prometheus configuration with 15-second scrape interval, um, doing HTTP to the Loki at the same location where we're getting, that we're actually connecting from Grafana to. And I'm going to do a deployment that runs a Prometheus container exposed on port 9090 using this configuration, and I'm creating a service for that. So let's run this. So kubectl apply -f. Let's paste this in. So that has created our Prometheus. We go back to Grafana. We go to configuration, data sources. We add another data source, Prometheus. And by the way, when I first heard about Prometheus, I didn't really know anything about it. I actually used the TGIK episode that Joe ran. And then there was another one, I believe, so I think Joe did sort of the background on what is Prometheus, its roots within Google, and sort of what are the concepts. And I think then there was another episode that actually talked about how to write Go code to actually create an application, to create a service that actually exposes things to Prometheus. And I think it explored the Prometheus operator for Kubernetes as well. And so that's how I got started with Prometheus, probably by now, like 2 or 3 months ago. I see. Um, Hi to Bucharest. Cool. So I guess the usage document is just a little bit out of date, and this has actually been updated. Interesting. Okay, that that makes sense. That's also why I was pretty sure I had seen a demo that did this. So I will add Prometheus 9090, and let's see, save and test. This worked, and so this should mean that under Explore, I now have Prometheus, and it should have a bunch of stuff. Cool. So let's see. One of the things exposed is chunks per corrupt chunks. We don't really want corrupt chunks, but we want, what do we want? Sort of disk cache. Let's explore a little bit what we have here. So what I wanted the ingester. Loki ingester. So I wanted to see how many chunks we have, and the count should do that. So the count is 0 right now. We don't have any chunks. That's probably because we haven't done really enough yet. So actually, let's not do 6 hours. Let's look at 5 minutes. All right, cool. Perfect. On the chat, you will find the link to Joe's episode, as well as the one that Chris did on instrumenting Go and using that. Yeah, somebody points out that the Loki support in Grafana is a bit experimental. I think the entire explore mode is experimental. You only get it on the master branch. You don't get it in a released version. And Loki itself seems to be quite experimental. So everything we look at here seems pretty fresh off the open source boat. So that's okay. That's it's still awesome to try out. All right, so I have set up Prometheus. So I'm actually set up to do my benchmark now, because now I can actually observe what the benchmark is doing. So um, with that, let's look at, well, I'm still not set up. All right, so I'm an idiot. So another thing I need to do is I have this S3 configuration here where this is the Loki configuration, and I prepared this where basically I'm telling I still want the built-in Bolt DB, and Bolt is similar to SQLite. I did some research on this. It's basically like a SQLite, but not a SQL store, but just a key value store. And as long as we are running a single ingester, the key value store for all the metadata, right? Which streams exist, which timestamps exist, and all that can actually just be stored locally. So locally in the file system. And so BoltDB is used for that. And for our experiments, we still use that. But I want to use S3 for my object store. I will actually not scroll down because I have my credentials here, and I'm pretty sure that somebody on the stream will hack me if I actually show you. So let's try to keep the secret. And all right, cool. Thanks, Paul. It's officially beta. Cool. So Loki is officially beta, so that's great. So let's create a S3 conf. Let's paste everything in here. And so now let's explore this. So there is a secret, the Loki secret. And that holds the configuration. Being a secret, which is good, but we cannot really see it nicely here. So what I'm going to do is pretty crude. I'm going to delete the secret. And now you will see that I'm a developer like everybody else, which means I don't actually know how to create a secret. I Google. All right, kubectl create secret. So let's mimic this. We create a secret. We call it Loki. We do a from file. It's called loki.yaml, and we provide our s3.yaml. No, I called it .conf. Okay. And now I don't know if that automatically updates, so I'm not going to assume that. So I'm going to be, again, very crude. I'm going to kill the Loki 0 pod, and I know that there's a stateful set behind it, so it will just restart it. All right, let's wait for that. Well, or let's not wait for that. Why is this taking so long to terminate? Okay, I'm not liking this. All right, my new container is creating, and it's running. Great. So, so now that we have this set up, this should now be connecting to my S3. What I'm going to do is show you a little script I wrote. So I looked up in the Loki repository. There you will find a little Python script that I took and extended, and here I'm connecting to Loki 3100. Let's see. So basically what we're doing here is we're forming a JSON payload. And the JSON payload is basically updates one stream at a time. And we put our labels that we want. And then we create a number of entries. And each entry is basically a timestamp and some line that we're putting in. And so the input here is how many of these log lines we want to push in one go. and I'm just going to return, the total number of bytes that I actually put in. So this is send message. That's sending one message. Then I have a number of log lines that I want to create. That's 80,000. I have a number of jobs, which are basically log streams, and I want to do 100 of them. Well, maybe actually let's do 50. And then I'm going to loop over how many iterations do I need to do, given how many lines I do per invocation, which is 100. And I'm going to call this send message. And so this basically, for one of these log streams, it will iterate and send as many messages necessary to create these 80,000 log lines. And then I'm going to run two threads or two processes, and they're going to pick up from the number of jobs. So that's 50. So each one will do roughly 25, and they will each call the send job logs function. So and at the end, it prints how many megabytes it actually produced in logs. So simple script, but it should be useful. So by now, this should also be ready. Yep, this is ready. Cool. So let's call it push.py. And one thing I'm actually not entirely sure of, does this actually work? Can I do a ping Loki? No. Okay. So what I'm going to do is I'm going to do another expose. I'm going to expose Loki 0, the port 3100. I'm going to call this Loki external. And I'm going to do a get services. And so my Loki external is here. And so what I'm going to put in is localhost at this port. All right. And now I should be able to do this, and it should be pushing a whole bunch of data. Let's try this out. All right, so we see that it's doing roughly 2 jobs in parallel, and we're going to put this into the background. So now we can watch this, and what we see is that, well, Python is actually consuming quite a bit to do these REST API calls, but we see that we're roughly consuming 85% of a core. And there's also some error messages, but we're going to ignore those. And we're going to let this run. And now while we're doing this, let's go back and let's actually look at this. All right, cool. So what we're seeing here, and we can do an auto refresh every 5 seconds. So we see now that the number of chunks that were ingested is going up. And that's great. That's what we wanted. And we can also see that if I look at my S3 bucket, I should start seeing some data popping up. Let's see if that's true. Is it not happening yet? Last modified. All right, there it is. So on June 28th, that's right now, we're creating, and given that these log lines are pretty similar, we're producing roughly 260 kilobytes for a given chunk. They are compressed. I actually tried downloading these, but they use a binary format that wasn't very easy for me to decode. I actually got a pointer to the binary format for me to poke, but I was hoping that I could just unzip them and take a look and just see the raw log lines, but that wasn't the case, unfortunately. And that makes sense, but it would still be cool if there was a little binary that I could run this through and actually get sort of the log lines that correspond to that. But we will just trust that there's actual logs in these things. So we see that things are going up here, and let's actually print another thing. So now there should be some S3 metrics. This is actually under Cortex, I believe. So let me see. I took some notes because it took me a moment to find the right metric. So let me go here. So the metric is called Cortex S3. Okay, so let's actually see here. 1 second. Let me just interpret what I got here. So we see that we uploaded 250 megs, and it took 59. So let's collect these timestamps. And what was the first timestamp? There were a bunch of errors, so I don't want to debug this right now, and I guess this is one thing I don't yet fully understand how the buffering and any potential back pressure works. Whether I overwhelmed Loki and how it dealt with that, I'm actually not entirely sure about that. But essentially, it took roughly 2 minutes to push these 250 megabytes. So what is that? So we have Python 3. So we have 250 megabytes divided by roughly 2 minutes, which I should have been able to do in my brain, which is roughly 2 megabytes a second. I think when I didn't get some of these errors, I was actually able to push more than that. But let's assume for a second it's 2 megabytes a second. I assume it's actually going to be more, but let's go with that number. So let's go back here. Let's go back here and let's take a look at S3 request duration seconds count. Right, so it's basically the same thing in terms of numbers. And we see that we basically on the S3 put objects, we had how many? 50. So we pushed 50 objects, which makes sense because I created sort of 50 jobs, and they didn't have enough log lines to actually create multiple chunks, and so they all ended up being a chunk that was pushed. Oh, I have an issue. All right, it sounds like there's an issue. Okay. Now, obviously, I don't know where things cut off. what I was doing in the meantime was I checked on my S3 bucket. I saw all the things that were uploaded, and I checked the metrics here, and we see that if I now go to 15 minutes, that we had 50 put requests sent to Amazon. All right, sounds like I'm correctly back. I don't know what happened there. Sorry for that. I just restarted streaming and it seems to be working. All right. So basically we did a 50 put requests, and now um, let's actually do a search. So I can use split mode. I can do Loki, and I will do a time range search that is now minus 15 minutes to now minus, I don't know, 5 minutes. And I will search for foo equals bar, which is what I uploaded. And I get a whole bunch of these test logs, and basically um, they now should be coming also from let's actually expand this search. Okay, and right. So we can see that that the search actually works, and if I go further back in time, let's try 12 minutes. So we can see that sort of if I want to just get those oldest ones, is there a good way of doing that? I guess we don't need to refresh this often. Right. So what's not showing up here? I'm not entirely sure if I'm getting the timestamps right, but essentially this should also be showing that I will eventually need to do get requests instead of just put requests, and they don't seem to be showing up yet. So I will not dive into that too closely, but when I was preparing for that, that definitely worked, and some of the get requests were being served. Some of the logging was served by these older things. So maybe if I search for 001, maybe this will eventually show up. So that's okay. Now, what I wanted to do was I wanted to go back to the architecture perspective, where if we look at what we've done is we let me see. So basically, we had this picture here, and in this picture, we had the ingester filling up memory, and now we should be thinking about this. What do we want? We want to, from a cost perspective, every request to S3 costs us money, right? And so we would like to actually send as few objects into S3 as possible. And so we would like to create large objects that we send in. But the larger the object, the more we need to buffer in the ingester. And so if we have 1,000 pods running, each one possibly generating an info and an error stream, that would be 2,000 streams. And so if I have 2,000 streams and each stream has, let's say, 2.5 megabytes, then I would end up with 5 gigabytes in memory that I need, which still sounds quite reasonable. But essentially, the math goes that I need to be, that my memory is an equation where the number of streams that I'm trying to support times sort of the chunk memory determines what's going to happen, how much memory I actually need. From a CPU perspective, though, the key thing that we saw was, we were running, what was it, 0.85 cores, 0.85 of a core, and we were running at 2 megabytes a second. So for every 2 megabytes a second that we want, we need to spend almost a core. And so this equation basically tells us what our CPU efficiency is. And so if we want to ingest, let's say, a terabyte a day, we can break it down to how many megabytes per second, and we can calculate our CPU consumption. And so what Loki then can do is it can actually, if that needs more instances of the ingester, well, it can scale out, so it can add more ingesters. And so there can be, actually many ingesters. Let's make them smaller so that I can draw many of them. And so you actually get many ingesters. And let me just check whether I'm still streaming correctly and whether everything is happy. Seems like people are happy. All right. And so basically uh, we can scale the ingesters. The other reason that we actually want more ingesters is because we might want to protect against loss. So if one ingester dies, it takes all the logs that were still buffered in it that weren't written out to S3 yet. They are actually going to be lost. And so one tactic here is that we can actually make the distributor do a replica. So the pod would also stream its data into another ingester, and that other ingester would also send it to S3. And so we actually have multiple ingesters getting the same memory. And for an enterprise storage person, I cringe when I see this because, total power failures, in my experience, do happen, and you need to be protected against actually all your memory being lost. But I guess for logging and from a cost optimization perspective, this is actually a perfectly fine trade-off to do, and we can put it into 3 pieces of memory, and we can do that. And what I heard was Loki's also working on a mode where it's actually doing this persistently on disk, but obviously writing every piece of log to disk instead of just to memory is going to increase our storage cost. So this is an interesting trade-off here, and probably a perfectly appropriate one for the use case. So so this is redundancy, and this is sort of the sizing. So with that, let's actually look at this. Let's imagine that what we're trying to do is we're going to do 1 terabyte per day. And so let me do some math for that. If we say that we have 1 terabyte per day, which means 1024 megabytes per day, divided by 24 to get hours, and divided by 3,600, we're actually not getting that much. Is that right? Well, okay, I'm dumb. A terabyte is more than 1024 megabytes. It's actually 1024 times 1024, so it's 12 megabytes a second. So if we assume the numbers that we saw, and again, I think in a prior experiment I was actually getting a little bit more than that, but if 1 terabyte a day is what we are dealing with, then and see, we have 12 megabytes per second. We argued that we need roughly 1 core for that, and for per 2 megabytes. So that means we need roughly 6 cores without redundancy. But then with redundancy, let's assume we're going to do 2-way replication, or even let's assume we're going to do 3-way replication, because we actually really don't want to use logs, and we trust that we don't have a total power failure across AZs, which is probably a reasonable assumption. then it's going to be 18 cores. From a memory perspective, as I said, it really depends on the number of streams. Even if you have several thousand, which seems like a reasonable number to go with, we came up with just needing 5 to 8 megabytes. And given that we're going to run at least 3 of these ingesters, well, we're going to run a whole bunch of these ingesters, and we need 18 cores. So let's say we're actually not going to do 2,000 streams. Let's say we're going to do 20,000 streams. So we need 80 gigabytes in total. So let's say we need 80 gigabytes on the high end side, and on the low end side, we need 8 gigabytes. So low end, I mean, 2,000 streams is still quite a bit. So let's go with these two numbers. And we're producing 1 terabyte a day, which means that we are producing 30 terabytes per month. And let's say that we want to actually keep logs around for 1 month. So with that, let's actually scope out how much this would cost us as a very rough approximation. And I know this is not the full scientific thing, but this is probably close enough. So let's go to the AWS price estimator. And so the first thing we're going to scope is that I want an EC2 instance. And I'm going to run 3 instances. And what do I want? So let's see. Let's just pick something that seems reasonable. So we said that we need 6 cores times 3. So let's go with 8 cores. And 32 gigs of RAM is somewhere in the middle of what we said we would need. So let's just go with that. Let's assume this is the instance we need, and leave it at that. And so that would equate to 730. This would equate to 730 dollars per month for our EC2 instances. And let's look at S3. Well, we wanted to store 30 terabytes. Okay. But aside from storing 30 terabytes, we need to also think about how many requests are we going to do. So let's do some math on that as well. So let's actually scroll a little bit here to get us a little bit more real estate. So we said, and in our experiment, we ended up with every object being roughly 250 kilobyte per object. Given that we are doing a 3-way replication, we're going to end up with roughly 750 kilobytes per object. Actually, let me equate this differently. So I really want to know how many put requests I'm doing. So if I have my 1 terabyte a day, basically, in a month, I'm going to write 30 terabytes times 3. Oh, actually, I should fix this. So I have, given that I do several a day, right? I'm actually doing 3-way replications, so I'm actually ending up with 90. I'm ending up with 90 terabytes that I want to store, unless I'm doing some deduplication, and I think that is something that the Loki folks are also interested in exploring further. But for the moment, let's assume we're not doing that. So we have that, and so let's assume we have 90 terabytes, and we divide that by 250 kilobytes. How many objects is that? Well, let's take a look. And yes, I know that I'm butchering units. So 90 times 1024, we need to go from terabytes to kilobytes and do 250. So we end up with, what is this? What is this number? 38 million. So we had 38 million million objects. Let's take this number and let's put it in here. And so for the ingest portion, and we haven't really scoped the query push portion yet, right? And the query will also consume resources, but but for this volume, which is quite a bit, to do a terabyte a day, we're basically getting a S3 bill of 5,200. So let's record this. $5,200 per month, and so these are our key numbers for, and this is for the ingest. And if we do, and now it all depends on how often do you query, right? Like how often do you have incidents where you actually need to query, and how many will that cover? And I don't have a good model for that right now, but you know, you will occasionally need to unzip in the querier. You need to run grep, and so. Uh, I don't know what's a good estimate for how many queries you will actually run in production. Um, and so, what would it cost us if we were to fetch everything once, which is probably too much, but that would just be another $100. So I guess that seems pretty reasonable. Doing a lot of GET requests was not going to cost us that much. There's going to be CPU costs. So, let's assume from a CPU perspective, and we don't need as much memory for the queryers, I guess, but let's assume that we have another cost like this. So, so let's assume that, maybe a very rough estimate. And, I hope that this is something that somebody does a little bit more scientifically with some real world experience. But let's assume that we have roughly 6,000 that we calculated up there. We're going to budget another 400. Let's say we don't need all that redundancy, so let's budget another 200 for the queryers, and for the actual queries, let's also budget 100. So in total, we end up with something like 6,500. Um, and if you look up what Splunk or Logsy or others do, they definitely range in the many 10,000s of dollars for the same log volume. So so definitely this is interesting, and this is something that comes out at a much more reasonable price, or a much lower price than what you would get from Logsy, for example, or from Splunk, or if whether you run that on-prem or in the cloud. So um, so I'm hoping that the Loki project sort of comes up with some real life numbers, as well as sort of a calculator for this. But this all looks quite reasonable to me. Cool. With that, I think I have concluded most of what I wanted to look at today. Um, are there any questions on the chat? Anything else that you guys would like me to take a look at while I'm there? I hope that those calculations for for the cost are interesting and make sense. I was definitely interested in what this comes out to be, given that at VMware we produce a lot of logs, and you know, sort of storage costs are our bread and butter. But I really didn't have any good notion for what this would cost. Let's actually do this. Logz.io. Do they quote a price? Let's see. Daily capacity. So I wanted enterprise contact sales. Cool. Choose your daily volume. Let's say I do 100 gigabyte of daily volume. So 100 gigabyte of daily volume would be 5,500. So if I do this times 10, that would be 50,000. So I guess the rough math where the Loki presentations claim to be roughly a factor 10 seems to pan out roughly from here. Obviously, I assume that the enterprise version has some additional features. I assume that you also in the enterprise version get some volume discount, but roughly this actually seems to pan out. Cool. So this is what I have today. Thanks everyone for joining and letting me ramble for an hour and a half. And sorry for that little bit of a hiccup where my MacBook just decided that I was done. And thanks everybody for staying up late. Just a word of advice: if you're in Europe and it's Friday night, get a beer, watch the recording. I won't be offended, or I assume Joe won't be offended. And if you're in India and it's 1 a.m., you should sleep. Sleep is important. With that, thanks everybody for joining. This was fun, and I hope to do this again. I really enjoyed this. Thank you. And now I need to figure out how to stop this. And I hope everybody will join us again next time.